Hello, everyone, and thanks for joining me today at the Tech Conference 2021. My name is Shadi Ashnai, and I'm talking today about video processing and analysis in the Wolfram language. We have started this development over 2 years ago and we have developed so much, and the development is not slowing down at all. So a lot is coming in the upcoming version of the Wolfram language, version 13, hopefully very soon. And as I said, more development we expect to come in the following versions. Today I'll give an overall presentation about where we are at with our video processing and analysis and a quick overview of what comes next, in hopes that anyone who have seen this or previous versions of this talk or those who haven't seen it are going to be able to catch up and see what's the overall state, and those who have seen it are still going to see a lot of new things. Okay, yes, we have continued development of video computation in the Wolfram language, really full speed. And we believe that this is going to be what we are offering is going to be one of the most powerful and flexible systems to compute with videos, edit them, process them, which is the beginning of whenever somebody has a video object or a video file, to advanced analysis backed with our large stack of functionality in machine learning and neural networks. What I'm going to be talking about is showing where we're at with the video objects in the Wolfram language, ways that we can create them, which there is a whole another talk about it after this, how we can easily edit videos, and ways to process and analyze video objects. Version 12.1 was the first version that introduced video object as the first class citizen in the language. What is coming to the Wolfram language now is a different GUI compared to what we had before, which was just a thumbnail GUI, something like that, which opened up the video outside in your default player. Now, this basic GUI that we are enabling, hopefully, most probably in this coming version, is going to look not exactly like what you see in that presentation notebook because of some magnification issues. It's more like that. So it's going to be a neat player with a play pause button, a slider that goes through, plays the audio. If the video has audio, has controls for volume and device and so forth. So it's still simple and basic, but it's pretty neat and complete for whatever people need to do with a video object as far as playback. One can look at information about any given video. Like in this case, I have 3.5 seconds of a video at a given bit rate, what's the resolution, encoding, other properties of the video track, if there are audio tracks or subtitle tracks, properties of that, and so forth. Properties of a video can also be directly extracted by functions like duration. We have extended that to take some image property functions like image dimension, so directly that could be queried, or things like audio channels. So in addition to be able to construct such video objects from local files, we can create video objects from other sources, such as URLs that are of any file format that is supported. We currently support all common popular formats, MP4, Matroshka, OGG, QuickTime, and so forth. If I create a video object from this URL, still I get a thumbnail view, and we're going to be continuing to work on having in Notebook Player for video of URL objects. And if I click on that, a browser is going to come up and play that video, allow me to play that video. However, as far as processing and analysis, everything is going to be exactly the same for local files as well as remote files. Cloud objects, as we are getting more of our content on the cloud, is going to be really similar to that experience of a URL. We have added video samples to Wolfram Data Repository. You can submit video samples or video collections to Wolfram Data Repository. And if I create something like that, the file under that resource object gets downloaded, and at that point, this is treated as a local object. For the time being, because we have this magnification issue, let's switch to another appearance, which is a minimal appearance, which just gives me a play pause button, basically. Okay, what are the ways that we can create easily video assets from within Mathematica? Video creation for the sake of video creation is neat and interesting, but also one of the reasons why we are putting some emphasis on video creation is that mathematical Wolfram language has always been rich in two things. One, the very rich graphics language that we have in the system, and two, the interactive user interfaces, mainly manipulate, list, animate, and so forth, which we have built a whole website, demonstrations.wolfram.com, all of which are all of those manipulates are available through resource data now. So this is a manipulate object. I can go ahead and play with this. And one of the early ways of creating video objects, which was introduced, first version that video was introduced, was to go ahead and create a video object from such manipulate expressions. So the one I had above was a manipulate where controls were interactive. And now when I wrap video around it, I get a video object which can be played as if that manipulate is evaluated. This video is mute as a convenience or as a way of editing videos. We have added this video combine function again in an earlier version of the language, where you can take that video object which was constructed above and add any audio to it. Here I just again extracted the title of the same demonstration through resource object, and I combined that with that video that was created. A lot of these are pre-computed so that we don't have to spend the presentation time on
bicycle
that.
wheels using curves of constant width.
So as you heard, this is the same video with some audio overlaid on top of it. Evaluating expressions. This is something that we introduced in last version or the version before it. Again, this is pre-computed. Very similar to how we could do manipulate of an expression. We have added this function animation video, which takes an expression that is evolving, and every step of that evolution is basically stored as a frame in a video file. So in this case, we are looking at an evolution of cellular automaton, and that's what the video captures. From a webcam. Again, an earlier version, we have added video record, which is in the bigger family of video streams. One can connect to a screen or to an imaging device and then record videos. And this is me from earlier today, recorded using video record. And then one recent thing, which you're going to see more of it in the next talk, is a new function called tour video, which basically starts from any 2D construct, like in this case, a mesh region, and then allows for navigation around that tour. We are really excited about this, as I said, because we think we have the rich platform of creating graphics, 2D graphics, 3D graphics, and also interactive interfaces. And for that reason, there is a big focus on video creation. With that, Carlo is going to be talking about video generation after this talk in a separate presentation. What is available to us in the Wolfram language as far as video editing? First version, we added a handful of functions like video trim, video split, video join, mostly things that are editing video over time. So here, looking at the citrus in the water video that I showed earlier, this is, I think, about 13, 14 seconds of a video. Let's look at its information, 9 seconds. And I can do something like, I just want to look at 2 seconds of this from second 3 to 5. And all of these could be numbers which are interpreted in seconds, or could be time quantity. So if you're looking at an hour long, 2 hour long, you can say exactly from 1 minute, what second to which portion. So this is just 2 seconds of that video extracted. In this upcoming version of the language, version 13, we have added support for frame-by-frame editing of video objects. So functions like video crop and video resize are adapted to basically work with video objects. So this is a cropped version of that same video I showed above, and this is a resized version of that video. Along with that same effort, we added support for more image processing functions to take or accept video functions. Like in this case, we are running color negate, which let me run it. It's not going to take long. Just for you to see what's the performance. This is the full 9-second video. It has to go through frame by frame to compute the color negation on every frame. And there it is, the negated version of that original video that we had. And again, along with that, we have added not all support for all image functions, but we are going to be looking at all image functions and seeing which ones make sense to adapt. So this is, for instance, just an effect, a stippling effect on that same video. Again, everything frame by frame. And a couple of functions that we have added, again, in this upcoming version of the language are mainly focused on combining videos. We also have generic functions like video map frame or video map, which is a more general function, which accepts a list of videos, and you're allowed to do whatever combination of videos that is in your mind. But as utility functions, easy to use, there are two functions, overlay video and grid video, which allows for two very common ways of combining videos. So here I have the same video of citrus in the water, and I want to add a logo of Mathematica to it, and that ends up to be the result. Here in this next example, I flip the image, for instance, if I want to have more space on the other side, and then video overlay again. Did I evaluate that or just open that? So I don't know if that percent is the percent that I really wanted, but I wanted to show that there are really easy ways of editing your video. For instance, rotate it, flip it, resize it. And then, okay, so the previous thing I had there was the negated video. Shows the purpose, basically. Any editing you want to do basically can happen on the fly, and then the combinations could happen there. Now, the second function, a grid of video. Just like when we are at a Zoom meeting like we are now and we are sharing our videos, there are a whole bunch of talking heads, and we want to see a grid of those. So in this one example, I resized the video so that this doesn't take a whole lot of time, but I basically created 4 effects using image effect, and these are previews of those that are happening. And then as a result of grid video, I'm combining the 4, adding some spacings with a white background, and that's what it is. Frame by frame, things are being connected to each other. Again, these are 2 most common combining applications of videos that we have. More of these convenience functions are gonna be coming, but we do also have the generic functions like video frame map and video map, which take multiple videos, and you can apply any operation on those. What else can we do as far as processing videos? Already in previous versions, we have added, okay, we could do things like, we have had a lot of neural nets in the repository, or even not in the repository. We have capabilities, rich neural network capabilities that can present neural networks that are state-of-the-art from the wild, converted and workable in the Wolfram language. Here I'm looking at one net from the Wolfram neural net repository. Again, doesn't have to be from that. That is mainly the task it's doing, it's colorizing one single image. And here, basically, I'm just preparing that network to take the image. What it does, it changes the A and B, or returns an A and B channels in the lab color space, and then I'm sticking back the original image as the L channel. So if we look at the colorization, let me run these so that the example actually shows. So that's my network. This is my evaluation functions. And if I colorize this grayscale image, you see that a colorized version of that comes out. Now, just for the fun of it, I've looked up an old Charlie Chaplin's video from the archive.org that's the link if you want to download it. I have the video downloaded and available here. So that's the file itself. I've just in order to conclude that computation more quickly, I've trimmed 10 seconds from the middle of that video. And then colorized it. So again, easy things. Video frame map takes any function like color negate or image effect or anything else. But in this case, it's taking a function that is backed with a neural network. But again, it shows the power of when all of our capabilities are coming together from different fields. And again, we really believe with all of that, we can be we will be, or we are already, one of the strongest systems for manipulating and computing with videos. Now, frame-by-frame computation, what one would say is one type of processing videos. One other type, obviously, which is more appealing, more interesting in general when it comes to video processing, is when we look at multiple frames or a sequence of frames and then perform computation based on those so that we don't have a lot of noise from frame to frame. For instance, in this example, we're looking at a denoising network, which takes 5 frames at a time. So again, let's look at the network itself. This is not yet published in the Wolfram Network repository, but it is ready and available, and it will be published pretty soon. We're looking at a noisy video of a horse riding. So that's our noisy video. And then I'm not going to evaluate this. This is a little slow as far as the network is slow. It's a bigger network, but you can see that the result of denoising is pretty clean and neat. Again, a lot of these operations would benefit from the fact that we're looking at multiple frames at a time. In this case, 5 frames at a time, and I'm sliding my window 1 frame at a time forward. Other examples, if you want to remove the background of a video, you really want to see the motion across video frames. It's not going to be as neat and nice to look at 1 frame and just remove background, or in this case, do the denoising. And the key here is a video net encoder, video frames net encoder that we have added to our neural network set of capabilities so that things like that are going to be easily doable now. As far as video analysis, this is what we have said before, and we still believe in it. This is going to be one of the most powerful things that people need to do, and I think it's going to be really easily doable in our system as well. The reason is that there is going to be, or there is already, a lot of video data out there, and it's time consuming to review all of them manually. So automated analysis is going to be the key to understand the videos, even if you want to do processing like blur the faces that you find in these images, we need to be able to find them, or remove the background. We need to be able to find what are the scenes to identify what are the backgrounds. So analysis is going to be the main key to a lot of the video computation solutions. And here in this slide, I'm showing a few examples of different kinds of tasks that are already very easily doable in our system. Here we're looking at basically a small room. And here we're looking at the this is the other GUI. We're looking at objects highlighted, detected objects highlighted on that same video, including chairs, dining tables, plants, and so forth. Again, things that are doable or was doable already on images, but you see how easily this is now applied to all frames of a video and then highlighted on top of that. Another example of frame-by-frame analysis, here we have a video of a few people, and with getting a little help from our old function, find faces, we can basically figure out how many people were present in at every frame of this video. But Now, this example, which Stephen used in one of his blogs, is basically using the same thing, but then upping it with recognizing faces as well. So in this example, we're looking at a Star Trek promo and wanted to see how much each person showed up in the video. In order to do that, we collected a bunch of images through web image search of the main characters of Star Trek. We ran a face recognizer. Doesn't take very much, but again, we don't have a whole lot of time. I'll let you play with this. It's all in the presentation notebook. And then looking at this
Next
promo
on
video,
Star Trek, data is reassigned for research purposes.
We basically map a recognizer function over frames of the video, and we can easily find a timeline plot basically of when each of those characters showed up in the video, how frequently they showed up, and we have other people which were not recognized through our recognizer. So there were other people there as well, but for the main characters, we also have a line plot or a timeline plot. Along the lines of video analysis, one of the very powerful things that is available out there, people have been doing a lot of research on it, is video classification. Video classification, like image classification, which is identical to what we have as image identify, is one task on its own in order to be able to say a person is jumping, a person is running, or something like that. But in addition to that, it's going to be really useful if we want to identify classes of unknown, basically identify previously unknown classes in a new data set. Think about it. In image identify world, we used to have, we do have an image identify which can identify a cat from a bird from a tree. However, we can utilize those same networks that perform that classification task on identifying sick cells from healthy cells. We can identify one type of a leaf from another type of a leaf. So those features that are being trained in these neural networks are really powerful tools for identifying or classifying other types of unseen classes of objects out in the world. So in this example, I'm looking at a neural net, a classifier neural net, again, recently added to our repository of neural networks, that basically it performs a classification task. If, let me run this. If you look at how many classes and what are the types of classes, this is 600 classes that could be identified, and these are samples of the classes that are available in that neural network. So if you have examples of exactly those sort, those could be identified through this network. Let's look at one example here, which we have an example of barbecuing. Let's see how well the network is operating on that example. It's thinking. If it proceeds, maybe give it one chance of proceeding with that. And if it didn't proceed, if it just didn't like it, we'll stop. Okay, so let's abort that computation. However, the first identification of that network is in fact barbecuing. It's one of the classes and it wasn't confused. If you look at top probabilities, there are other classes that would be identified in that for that video. But in this case, okay, I don't have the results showing. I'm not going to attempt at running this again. However, okay, so that's that. Now, the one thing that I wanted to show is that we can use this neural network or one of the layers of this neural network as a feature extractor. So if I look at two data sets, brushing teeth and cheerleading, and run that feature extractor or use that feature extractor as my feature extractor, you would see that these two sets of, these are interactive things that are not just showing up, but the cheerleading videos are down here, toothbrushing is over there. That's basically what I had to show today. Before we go, don't forget, if you have heard this before, our video functionality and in our system comes with a version of FFmpeg installation, but because a lot of video codecs are patented, we have to ship a limited version of FFmpeg. The functionality will greatly benefit from you installing FFmpeg on your machine. Instructions are out there. Video and video functionality is going to be under active development. I repeat that because we really want feedback. And for that reason of it being under development and us wanting the feedback, we are keeping it experimental. Hopefully this change is going to happen and our player is going to switch to an in-notebook player. However, do expect limitations. If you have a 4K video, it's probably not going to play smooth. We have tried it with 1080p, 30 frames per second seems to be what we can handle at this point. If you download my notebook, a lot of files are going to look like that. That's because our video objects are at a core. Download the files and reevaluate the results so that you get the proper assets in there. And with that, that's my new version of saying thanks with some kind of an animation video with graphics of just the word thanks. Okay, thank you very much for listening to me.
Hey, Shadi, there's a number of questions in the Pathful chat. If you'd like to address those, just feel free to read those questions out loud, please.
Thank you for all the excitement. Can we expect support of video streaming from online platforms? That's a very tricky question. We have looked into that. A lot of platforms, in fact, keep changing the URL of the live stream. We have had luck with a few of them not being changed very frequently, but video stream, the function video stream already accepts URLs of video streams. And you can, in fact, record those, but good luck finding the URL that's not changing. A lot of the platforms constantly change the URL so that people cannot constantly record and rebroadcast their live streams. If you have an IP camera or anything that is yours, obviously that address is not going to change. Andreas, I don't quite understand that question. I'm happy to chat as we are getting closer to the end of the talk. Video processing examples that make use of GPU acceleration. As far as encoding and decoding, we would utilize GPUs. If not by default, you can enforce through video encoding option so that the GPU is utilized. As far as processing, anything neural net that can run on a GPU, which our neural net is supported on GPU as well, you can just change the target device to be GPU and that processing is happening on the GPU. Again, Mike, more than happy to discuss on that further if you have feedback. Character tracing is something that I think not immediately doable. As I showed, we can track people and we can recognize them if the face is big enough. I haven't done, or none of us have done any example of making sure the right person is being tracked. So if two people are crossing or passing over each other, will the algorithm get confused? Probably so. And system install of FFmpeg, it was brought up internally as well. Again, it just requires very explicit user consent that the GPL library is being installed. So there is a little technicalities there. For now, the best that we could have come up with is there. We're looking into improving that as well in the future. Okay. I guess we are at the top of my presentation time. We're holding a meetup tomorrow at 10 o'clock. If more questions, we're happy to discuss with you then. Thank you, everyone.
Thanks, everybody. Thanks, Shadi.